Okay, so these notes are covering section 7.6, and we're talking about trigonometric equations. Now, we've done some sort of trigonometric equations already in this chapter. So, for example, sine squared x plus cosine squared x equals 1. Well, that's technically an equation, except that's a kind of a special equation, which we refer to as an identity. And so that means this is true for any value of x, or for any theta, any angle that we would put in. The sine squared of that angle plus cosine squared of that angle is equal to 1. So, but what we want to talk about is an equation that isn't, that doesn't work for any value, but for just some value. So in this section, we're going to be more interested in equations that are true for certain values of x, not all values of x. So we might look at an equation like sine x equals 1/2. All right, well, of course I say here the solution, but a solution would probably be better, right? So a solution to this equation would be pi over 6, because sine of the angle pi over 6 is equal to 1/2. So if we think about drawing a picture here, I go up here. So for this theta, for theta equal pi over, nope, sorry, I didn't really draw that to scale. Let me draw that a little better. So probably out this way would be better, more. And so theta is theta equal to pi over 6. So that's 1, that's 2, that's the square root of 3. So sine, of course, is 1/2, right? And so for this, one solution to this equation would be pi over 6. Now, pi, for example, is not a solution because, of course, sine of pi is not equal to 1/2, right? So just like solving equations, sometimes you get what's an identity, so any x value will work, but for most equations, you're only going to get certain values that work. And in Algebra 1, we often just got, if it was like a linear equation, it would have like one solution, generally. But here we're going to see that it's possible that it could have more than one solution. All right, because this function is periodic, the sine function is going to, you're probably going to guess that maybe it would have more than one angle that would have 1/2. All right, and so investigate this. What I've done is I've broken this thing up and set both sides of this equation equal to y. All right, so y equals sine x. Let's graph that. So I took this side of it and set it equal to x, and this side. So let's start with the left side. Y equals sine x. Let's graph that. All right, so sine, we know we're at 0 at 0. The period is 2 pi, so let me go over here to 2 pi. Half of that is pi, so I know I'm here. And then halfway between that, I guess would be about here, we'd be up at 1. And then halfway between here, which is, let me put in here, pi over 2. And halfway between here would be 3 pi over 2. And so that's down here at -1. All right, so let me see if I can kind of sketch this maybe. I don't know. That's probably not that. That's not too good. Hang on. Let me kind of sketch this a little better. And of course, it's not just there. We could go another negative pi over 2, and we would be down here, right? So, I mean, we could kind of keep going. All right, and then try to sketch this side in. Let's just do, our one period here. Okay. And of course, we could keep going. 1, 2, 3 here. We're going to be back up. Maybe at 0 again here. Let me just do the whole, even though we usually just do one period, let me do the whole thing here. 1, 2, 3. So here at negative pi. Okay. So now, we graphed this. Now let's also graph this. And so where those two things are going to intersect, it's like a system of equations, right? So that's easy enough. Y equals 1/2. That's a a horizontal line at 1/2. So it looks like something kind of like this, right? So you could see that we have multiple solutions. So here, sure enough, we found pi over 6 before, right? That solution we got. That's what we kind of came with up there. But if we think about it, where else is sine of an angle equal to 1 over 2? And so that would be over here at 5 pi over 6. So here we have 5 pi over 6. That's another solution. And then we have another solution here, another solution here. So this one gets repeated again and again and again. It gets repeated here, and it gets every 2 pi's. If I add 2 pi to this, I get another one. If I add 2 pi to this, 5 pi over 6, I get this solution. Okay? So there are indeed 2 places, a theta equal to pi over 6, and over here, a theta equal to 5 pi over 6. That gives us our 2 solutions, right? Our reference angles clearly are 30 degrees or pi over 6. Let me draw my things in here. So, and then also it helps if we are thinking about all students take calculus, right? Sine is positive in the first and second quadrants. So since we're dealing with positive 1/2, we know we're in the first 2 quadrants. If this was a negative 1/2, then I know I would be dealing with the stuff down here in quadrants 3 and 4. All right. And so how would we write those? Well, the answer is going to be theta. If we wanted to think about all solutions, theta, and that's equal to pi over 6. And then we would just want to add all the different possible multiples of 2 pi to that, or n times 2 pi, where n could be any integer, negative, positive, or 0. And then same kind of thing, theta equals 5 pi over 6. That's, this one. And then it's, here and here and here. So we could subtract 2 pi or add 2 pi. So plus n times 2 pi. All right, so that's kind of how you would write all possible solutions to that original equation up here. Now, sometimes what we'll ask is for you to give us the solutions to the equation in a particular range. So, sometimes we might say in the range of 0 to 2 pi, right? Something like that. And sometimes we'll say, find all solutions, and that way you'll want to do sort of this times a multiple of a period. All right, so let's look at example 1. All right, so what we could do here, we're going to solve this equation. We really sort of want to, sometimes we want to get the sine or the trigonometric function by itself. Sometimes we might want to set it equal to 0 and factor it. So let's take everything over. Let's take this stuff over to the other side. That gives us 0 equals 2 sine x, plus 1. And so there's no factoring involved here. So I think what we want to do is take the 1 over and divide by 2, right? So that's going to be negative 1/2 equals sine of x. And then we want to think about, okay, sine. Where is sine negative? Think about, an xy coordinate plane and say, okay, we know that sine is negative in the 3rd and 4th quadrants. So something like this and something like this, right? So we have negative 1 and negative square root of 3, and we have 2 positive square root of 3 and negative 1, if we want to label the sides, right? So where is this happening? Well, the sine, remember that the sine is y over r, and so we're talking about negative 1 over 2. So reference angle here of 30 degrees, or pi over 6. So what will that be? So this will be 7 pi over 6, x is equal to 7 pi over 6. And then what will this one be? So going from here all the way over to there, that is just pi over 6, shy of 2 pi. So that's x equals 11 pi over 6. Now they asked us for all possible solutions, not a particular range. So all possible solutions. So it's this, and then plus all the multiples of 2 pi, or minus the multiples of 2 pi. So plus, if we want to say 2 pi n, or we can say n 2 pi, and then same thing here, plus 2 pi n. So it's out to here, and then it's subtracting 2 pi or adding 2 pi. All the multiples will give us all possible solutions from negative infinity to positive infinity. Okay, now the next one is asking us to just do one revolution. What are the solutions in one full revolution from 0 to 2 pi? All right, so I think what we can do here is what we sort of want to do is like do a substitution almost. So because it's tangent of 3x, so I can't say what x is, but I can say what 3x. In other words, let me just write it like this: tangent, and let's change it. Let's say beta. Tangent of beta equals 1. All right. So what angle has a tangent ratio of 1? And so, okay, first of all, it's positive. So where is tangent positive? Tangent is positive in the first and third quadrants. So let's draw a triangle here and a triangle here. And we may not draw it perfectly to scale because we don't have the answer yet. We don't know maybe what that reference angle is in here and in here. We know they're the same angle, those reference angles. All right, so the tangent, that's y over x, so they have to be the same. So we can think about it as 1, 1, and square root of 2 if you want. Again, I'm not putting this on the unit circle, but you could. And then this will be -1 and -1 and the square root of 2. Okay, so I think you can see now that, reference angle 45 degrees or pi over 4. But we're not interested in what theta is, so just be careful. Let's first write out, I know that beta is equal to pi over 4. But, and also, okay, so in this case, it's straight across, right? So how do I get from this one to this one? I could just add pi. So instead of saying beta is pi over 4, and then 1, 2, 3, 1 pi over 4, 2 pi, 3 pi, 4 pi, 5 pi over 4. And so instead of saying it this way and saying plus 2 pi n plus 2 pi n, in this case, we can be more concise and just say, this is beta is equal to pi over 4, and then we could just add plus pi n, because for here we add a pi, we add a pi, we add a pi, we add a pi, or subtract a pi, subtract a pi, subtract a pi, because they're right across from each other. Unlike this one up here, we would have to write this one separately. We can't, to go from this to this is not the same as to go from this to this. But it is here because it's straight across. Okay. Now, that's not your answer because we're not asking what beta is. Remember, we did a little substitution. We took out 3x and put in beta. So now we take this and we write it as 3x is equal to pi over 4 plus pi n. And now we solve this for x because that's ultimately what we're interested in. And so now we would divide everything by 3, so we get x equals pi over 12 plus pi n over 3. All right, now we're looking for the actual, so in other words, we're not going to use this notation of plus 2 pi n or pi n. Ultimately, we want a list of all the answers all the angles in this range that satisfy this equation. So we don't want a list of all of them like this, but we want a list. So start with x, and let's do this. So we know if they were asking for negative infinity to infinity, then yes, this would be your solution, right? But now we just have to list them all. So pi over 12. All right, and then we just add 1 to it. Like I can't subtract because then I'm below 0. But I'll add a pi over 3, or it helps, we want to multiply that. So we want to add 4 pi over 12, each time, because we want to get a common denominator. So I know I'm going to add one of these, and I get 5 pi over 12. And I'm going to keep going until I get up to 2 pi. Don't want to go past 2 pi. So let's say I add another 4 pi over 12 to this, and that gives me 9 pi over 12. Now I can reduce that, right? 9 pi over 12 can be reduced. Keep going. Let's add 4 to that. That's 13 pi over 12. Add another, that's 17 pi over 12. And then add another one again, 21 pi over 12. And of course you could reduce that one as well. So probably good to go back and then reduce the ones that can be reduced. So this can be reduced and that can be reduced. But you can see you get lots and lots of them and really it's because of that 3. Right? So you're getting 3 times what you would sort of expect almost. So, before we would have 2 solutions. If it was just the beta, we had 2 solutions. Now we're getting 3 times the solution, so we get 6. Okay? And again, if we were asking you to solve it for all real answers, then we would just leave it kind of as plus pi n over 3. We would add that to it. All right. Now, what's really important though is that when you're doing this, you don't wait. You don't write this, then divide by 3 to get rid of this, and then add this to it. You got to have this written first, because that's got to be divided by 3. So not just the pi over 4 gets divided by this 3, but so does the pi n. So you got to make sure you have that included too. Okay. All right. Let's go on to example number 3. All right. So we are solving sine of pi over 2 equals 3 square root of 3 over 2, and we're asking you to give all possible solutions of this one. So you might pause the video and try doing this on your own, see what you get. All right, so we might want to think about where this would be. And of course, this is not, if it was just x, we could go directly, but you might want to do sine, say, alpha equals the square root of 3 over 2 first, and do like a little substitution, taking the x over 2 out. And so for what angle is sine going to be the square root of 3 over 2? So it's positive, so think about which quadrants we're in. And we're going to be in the first and second quadrants, right? And so we want the sine. Remember, the sine is y over r, so we want the y to be square root of 3, and we want the r to be 2 square root of 3, negative 1 and 1. So, of course, our angle, in this case, alpha, is going to be equal to pi over 3. And then that's plus 2 pi n. And then alpha is also equal to 2 pi over 3 plus 2 pi n. And now let's go back and put our x over 2. So we have x over 2 equals pi over 3 plus 2 pi n. This time we're not dividing by 2, we're multiplying by 2. So x will equal to 2 pi over 3 plus 4 pi n. All right, so that's one of our solutions. Because again, we're asked to find all solutions, not just in one, in a set, our set domain. And so the other one would be x over 2 equals 2 pi over 3 plus 2 pi n. And so we're multiplying by 2, so x equals 4 pi over 3 plus 4 pi n. All right, so those are all of the solutions. Now, if we were asking you to do this from 0 to 2 pi, and usually when we do this, we, if it is 2 pi, it's the same as 0, so we don't want you to do both of them. You would do one or the other. So we generally start with the inclusion of 0, but not the inclusion of 2 pi. So starting at 2 pi up to, but not including, starting at 0, but not going up to 2 pi. All right, and so notice too that that this doesn't double the number of solutions. This would sort of half the number of solutions, roughly speaking. So in this case, if we were looking for this, we would have, we'd have 2 pi over 3, but as soon as we put the next one in, 4 pi added to that would already be way over 2 pi, so we wouldn't include that one, right? And then this would be 4 pi over 3, but again, we don't have any others after that. So unlike before where we had 3x, then there were more, but here we're dividing by 2, so there tends to be a little less, so we don't have multiples. But ultimately, these are the solutions because we were asking you to go from negative infinity to infinity. All right, next one, example 4. So we want to be able to solve this equation. So if it helps, think of it as 2, I don't know, let's say 2y squared plus y minus 1 equals 0, right? I mean, think about instead of cosine squared x, what if it was y squared? And instead of cosine, it was just y. Well, we would be able to factor this. That would be a quadratic. So same kind of thing here. We want to think about taking this and factoring that equation. Right? Set equal to 0, and then factor it. So we have 2 cosine x, and then this will be a cosine x. Oops, lost my s. Cosine x. All right, and then 1, right? So it's going to be 1 and 1, and then one of them is going to be positive, one's going to be negative. The center term's positive, so I think this will probably be positive, this will be negative. That would be a positive 2 cosine x minus 1 cosine x gives us a positive cosine x. So that seems to work. And so now we just, like we would in algebra, we would take both of those binomials and set them equal to 0. So we have 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. And so this will be cosine of x equals 1/2, and cosine x equals negative 1. And then we just want to solve, these two. So cosine, all right, where is cosine positive? Cosine is positive in the first and in the fourth quadrants. And so this will be a 1, this will be 2, and 2, square root of 3, negative square root of 3. All right, so this, and again, we're only looking for anything between 0 and 2 pi. So this will just be the solutions from this. X will be equal to pi over 3. And then 1, 2, 3, 4, 5. X equals 5 pi over 3. And then for this one, we say, okay, cosine is equal, cosine x equals -1. Well, that's going to be over here, right? At pi, the cosine is equal to -1. So x is also equal to pi from this one. Okay, so if you wanted to kind of write that out in a set notation, you could say what? Pi over 3, pi, and 5 pi over 3. So, generally in order. Or just, box these in. It's just as good. Okay. Number 5. So why don't you pause the video for number 5, work on it, and look too that the range is not from 0 to 2 pi. This time it's from 2 pi to 4 pi. All right, so for this one, I think I could treat it as a difference of squares, but I think in this case it's probably just easier to move the 1 over and divide. So we get sine squared x equals 1/4. So taking the square root, sine x equals plus or minus 1/2. And so we want to think about, okay, so where are we now, right? So sine, remember sine is equal to y over r. And so we want to think about, okay, what's the reference angle? So the sine is 1/2. We're talking about a reference angle of 30 degrees, right, in here. So 1 and 2, square root of 3 if you had to. All right, but it's not just here, it's also over here, but we're talking about the negative as well, so actually we have all 4 of these. Let me get rid of that square root of 3. It's kind of in my way. So we're going to be in all 4 quadrants, right, all the possibilities. Now, be careful. Yes, the reference angle is pi over 6, but we want the angles that are between 2 pi and 4 pi. So we're going to have to get the coterminal angle that's bigger than that, right? So let's see, x would be equal to, we know we're going to have 4 solutions, pi over 6, but we want to add 2 pi to that. So that would be 13 pi over 6. And then this one will be, what, 5 pi over 6. We want to add 2 pi, but remember 2 pi is the same as 12 pi over 6 because we've got denominators of 6. So we want to just keep adding this. So add that to this. That's 17 pi over 6. And then this is 7 pi over 6. So that gives us 19 pi over 6. And then finally, this one would be 11 pi over 6. But again, we're going to add 12 pi over 6 to that. So that's 23 pi over 6. So that is the solutions to all of these in the range of 2 pi to 4 pi. All right. Number 6. All right, so again, you might, I've sort of, the problem is up here, but then I sort of did an erroneous approach to this. So think about what's wrong with me dividing both sides by tangent, right? And it's like canceling out the tangents. Then I just get this, right? And so I've lost a solution because I've gotten rid of that. So you can't really divide by one of these trig ratios, just like we couldn't divide by x, right? So if this was x times y squared or something equals 3x, can't divide by x and divide by x. That I lose a solution when I do that. All right, so same kind of thing here. We can't divide by the trigonometric function. So what we want to do is maybe set it equal to 0. Let's start with that. So it's got to be tangent x sine squared x minus 3 tangent x equals 0. And maybe now we'll try factoring. So instead of dividing by tangent, we'll factor a tangent out. So we get tangent x out in front, and we get sine squared x minus 3 equals 0. All right, so we set each of these equal to 0. We get tan x equals 0. We get sine squared x. I'm just going to jump ahead and say 3. Move the 3 to the other side. Okay. So now tangent of 0. Okay, so where is the tangent equal to 0? So remember that is tangent is y over x. So we think about when is the y equal to 0. So that's going to be, here and here, right? So x equals 0 and x equals pi. But look at what we want, right? We want the negative 2 pi to 0. So instead of 0, let's subtract 2 pi. So we're going to say x is equal to negative 2 pi. And then instead of pi, I'm going to subtract and get negative pi. Negative pi. All right, subtract 2 pi from pi and get negative pi. And then let's look at this one. I'm going to take the square root of both sides. So we get sine of x equals plus or minus the square root of 3. And think about where that is. And you have to think about it for a second and say, oh, the square root of 3, that's bigger than 1. Remember, the sign ratios fluctuate between -1 and 1, so this is not going to give us any solution. Right? There's no way that sine of an angle cannot be bigger or smaller, bigger than 1 or smaller than -1, and so that does not generate. So that is like no solution. Okay, so these two are the only two solutions to that equation. All right, try number 6. I would say at this point, pause the video and try number 6 on your own. See what you can do with it. I might just suggest that you might try using some identities. Okay, so I'm assuming you paused the video and you've tried this one. Remember, I have a cosine squared and a sine, so that's not going to help me. Like if it was cosine and cosine, then I could do some factoring, like up in number 4, right? I had cosine squared and cosine. I could factor that. But here it's cosine squared and sine. I can't factor those. It's like saying, an x squared plus a y. I can't, plus 1. I can't factor this trinomial because they're not the same. So we have to use some sort of identity to be able to change one of these out. And so I think we have some identities for cosine squared. Remember that cosine squared x plus sine squared x equals 1. So instead I could think of that as cosine squared x. If I move the sine to the other side, I could write it as 1 sine squared to the other side, 1 minus sine squared x. So that means where I see a cosine, I could replace it with 1 minus sine. So we need a little identity for this one. All right, so we have 2. And let's take out that cosine and use that identity. 1 minus sine squared x plus 3 sine x equals 0. Now let's substitute this. Let's, not substitute, but let's distribute. And then also I think what I'm going to do is I will multiply through by a -1 because I want to get rid of that. You can see it's going to be -2 sine squared x. I'm going to factor, and factoring is easier if the coefficient is not negative. Leading coefficient's not negative. So I'm going to multiply through. So distribute that 2 and also multiply through by -1. So that should give me 2 sine squared x minus 3 sine x, and that was 2, but I'm multiplying through by a negative, so that's -2. So we should have a positive 2 sine squared x minus 3 sine x minus 2. And hopefully that would factor. And if you had to, if you have a hard time with that, you can think of that as, 2u squared minus 3u minus 2, if that helps you to do the factoring. All right, so we're going to have 2 sine x and a sine x. And we have 2, so one's going to be a 2, one's going to be a 1. I think I want the 2 to multiply the 2, so we'll put the 2 here. That'll give me 4 sine x. And then this will give me, if I put a 1 here, that'll give me 1 sine x. The difference is 3. So we want this to be negative and this to be positive. And that is, of course, equal to 0. All right, and then remember, we want all possible solutions for this too, so that's going to affect how we do our answer. Set this equal to 0. That's what? Sine of x equals negative 1/2. And here, sine of x equals 2. So we saw before that, of course, that's not going to generate any solutions. Right? Sine of x can never equal 2. It can only be as big as 1 or as small as negative 1. But sine of 1/2, let's do this. Let's move this up here so we can have some more room. Get rid of that substitution thing I was doing there. Okay, so sine is negative 1/2. Okay, so where is that? That is going to be in the third and in the fourth quadrants. Remember, sine is equal to y over the r, so we want the y to be 1. Or negative 1 and negative 1, and this is 2 and 2. All right, so negative square root of 3, square root of 3. And so what angles are we talking about? Reference angles of 30 degrees, or pi over 6. So what's this one? This one is 7 pi over 6, and this one will be 11 pi over 6, but it's all of the solutions, so we'll do x equals 7 pi over 6 plus 2 pi n, and also x equals 11 pi over 6 plus 2 pi n. All right, so 2 solutions, well, infinitely many solutions, but 2 values in the first rotation, and then we're going to add 2 pi n to all of those. Okay, so to solve these, you're going to be using similar things that we did for solving equations, a lot of factoring, possibly some substitution, using some identities to take out things. We want the variables to kind of be the same if we're going to factor them, right? The trig ratio is going to be the same. Maybe one's going to be a sine and one's not going to be a squared and one's not going to be a square. That would give us a quadratic form that we could factor. Okay. Remember too, don't ever divide by a trig ratio. You lose a solution, right? If you did that, you really have just the second part, and you would lose this. So you would lose our solutions, right? Our 2 solutions that actually work, we would have lost if we had divided by the tangent in this case. So, all right, so down below here is your homework. Remember, times 5 is the multiples of 5. That is due next class.